Welcome to my kcse revision channel, Teacher James Marita, Grigorius Boys High School. Kindly subscribe to my channel, click the notification bell such that you can get notified once I upload a new video. You can also follow me in my Facebook page, Marita James, the Ocean of Chemistry. Today we are looking at industrial question, that is the conduct process of Form 3, and this question is normally tested in paper 2. So we have a flowchart in a conduct process. Conduct process is a process for the large-scale manufacture of sulfuric acid. So we have some steps which are involved in the preparation of this sulfuric acid. So we have the roaster, we have the purification chamber, we have the drying towers, we have the heat exchanger, the catalytic chamber, we have the absorption chamber, and finally we have the dilution chamber. In any industrial process, the main thing that is required is to identify the raw material. So in this conduct process, what are the raw material required for the manufacture of this sulfuric acid? So first of all, we have the raw material. The raw materials, one, we have saliva, we have water, and then you have air. Those are the raw materials required for in this conduct process. So in this saliva here, you can either have the saliva from underground, the underground saliva, or you can have saliva combined with other elements. For example, you talk of tomato salivates. So this saliva, you either have the saliva or you can have this saliva combined with other metals. For example, you talk of the zinc salivate, you can also talk of the lead salivate, or you can talk of the iron salivate. Or this one here, these are the metals that contains the saliva. So you can have from this saliva here, you either have the saliva combined with the metals, so you talk of zinc salivate, you talk of the lead 2 salivate, or you can talk of the iron salivate. So you will have saliva. The saliva is mixed with the air. The saliva is mixed with the air, a dry air, and then passed through the roaster. What is happening in this roaster? What is happening in the roaster is saliva combines with oxygen to form the saliva 4 oxide. If you are using the metal salivites, if you are using, for instance, the zinc salivate, zinc will combine with oxygen, will be roasted in the roaster to form the zinc oxide, and then we have the saliva 4 oxide. If we use the lead salivate, in this case here, lead salivate will be roasted in this roaster to form the lead oxide, and then we have the saliva 4 oxide. The same case applies when we are using the iron 2 salivate, whereby it will be roasted to have the saliva 4 oxide, and then we have the iron 2 oxide. So in the first case, we have the roaster. In the roaster here, equation of the reaction which is required, so you will have saliva plus oxygen, then you get the saliva 4 oxide. Then if you are using a metal, this is the type of equation that you will be having. After having the roaster, the air, which is now the mixture of air and the saliva, now we have a product of saliva 4 oxide. Saliva 4 oxide now is passed through the purification chamber. What is the role of the purification chamber? The role of the purification chamber is just to purify the gases. It is to purify the product of air and saliva. So in this case here, we have a purification. In the purification, the dusty particles and impurities are removed. So if you will purify, now what is happening in purification? Purification is done to remove the impurities to prevent poisoning of the catalyst. And also, what are some of the impurities which are removed in this purification, in the purification chamber? In the purification chamber, impurities removed. We have the dusty particles, we have water vapor, and then we have the arsenic compounds. So in the case a learner is required to name some impurities which are removed in the purification chamber. You just mention the dust particles, you mention water vapor, or you can mention the arsenic oxide. These are some of the impurities which are removed in the purification chamber. Otherwise, if the impurities cannot be removed, they will just poison the catalyst in that case. So the main point you need to understand from the purification chamber, the reason why the air, the product of this saliva and oxygen is being purified. And in this case, you identify some impurities which are removed in the purification stage or in the purification chamber. Then from the purification now, we have pure air, and then we have saliva 4. A pure air, in this case, the air which has been purified, it is now passed through the drying tower. In the drying towers now, the air needed to be dried. In this case, you need to identify the drying agent required here. So the drying agent it is normally required here. We are using the concentrated sulfuric acid. So the dry air, the pure air and saliva oxide is passed through the drying towers, and the drying tower in this case it contains the concentrated sulfuric acid. Concentrated sulfuric acid is a drying agent, so it is passed through here to dry the gas. So the reason why we have a drying tower, it is to dry the gas. And the reagent which is used in drying this gas is the concentrated sulfuric acid. Now we have a dry air and the saliva oxide now. They are passed through the heat exchanger. So what is the role of the heat exchanger? In the heat exchanger here, we have some optimum conditions required in this heat exchanger. So if you are required now to identify the conditions required in the heat exchanger, so you talk of, in that case, you will have an optimum condition. An optimum condition in that case, we have a catalyst, and the name of that catalyst is called the vanadium 5 oxide, or what you call it the platinum asbestos. There are two catalysts used here. We have the vanadium 5 oxide, or we have the platinum asbestos. But of the two, the vanadium 5 oxide is preferred instead of the platinum asbestos. Why? Because the vanadium 5 oxide, it is cheap and it is not poisonous. So another condition here, you will have a pressure of 2 to 3 atmosphere. A pressure of 2 to 3 atmosphere, this one will bring the molecules of gases closer for faster reaction. You will be talking about the factors affecting the rate of the reaction in form 4. So another condition here, you will have a temperature of 450 to 500. In an examination, when you are required to give these conditions, you are not supposed to give the range. For example, don't say a pressure of 2 to 3 atmosphere. That one is not allowed. Don't say a temperature of 450 to 500. That one is not allowed. You just say a pressure of 2 atmosphere or a pressure of 3 atmosphere, a temperature of 450 or a temperature of 500. Do not give the range when you are required to give these optimum conditions when answering an examination. So that is what we have in the heat exchanger, and of course we have in this catalytic chamber. So from the heat exchanger here you have the catalytic chamber. But what is the role of the heat exchanger? So it will be required to give the roles of the heat exchanger. It provides reactants with enough energy. It provides reactants with enough energy to react. What are in this case the reactants? The reactants here, you are talking about the saliva oxide and in this case oxygen. So when saliva oxide and oxygen react now, the gases will be converted to saliva 6 oxide. So the purpose of the heat exchanger, it is to provide the reactants with enough energy for enough energy to react. And again, it cooled the product. The product in this case, the product it is saliva 6 oxide. So the product of saliva 6 oxide can be cooled in the heat exchanger, preventing the decomposition of the product. Then we have another a role of the heat exchanger. It sustains the reaction temperature and then it recycles the heat, hence it reduces the cost of production. So these are some of the rules of the roles of the heat exchanger. So from the heat exchanger there now you will have the catalytic chamber. In the catalytic chamber, so you will have the catalyst. A catalyst here in this case, it increases the rate of the reaction here by lowering the activation energy. So in that case now, as I've said, we have two types of the catalyst used here. That is the vanadium 5 oxide or the platinum asbestos. So we will be required to give the name of the catalyst used. The name of the catalyst you just mentioned, platinum asbestos, or you can use the vanadium 5 oxide. Now, the equation in the catalytic chamber, so in this catalytic chamber, you will have the sulfur oxide now converted to sulfur 6. This is a reversible reaction, as you can see. This is a reversible reaction because it has two half halos. It has two half halos, so we call it the reversible reaction. So we have now sulfur 4 combining with oxygen. This one now will be converted to sulfur 6 oxide. So this is the equation that takes place in the catalytic chamber, and this, as you can see, the reaction is highly exothermic because a lot of heat is being generated during the reaction. From now the catalytic chamber, the gas, the product, that is the sulfur 6 oxide, is taken back in the heat exchanger. In the heat exchanger now, I've said that here now, they are taken back here to be cooled down. So once now these gases have been cooled, they are taken in the absorption chamber. In the absorption chamber, this is what is happening. Remember our raw materials we have sulfur, we have air and water. In this case, we have not used water. Here, we are not supposed to dissolve the concentrated, we are not supposed to dissolve the sulfur 6 oxide direct into water. That one is not the case. The gas is dissolved in a concentrated sulfuric acid in this absorption chamber to be converted into a substance called helium. So that is what we have here. We have the sulfur 6 combining now with dissolved in a concentrated sulfuric acid. When a concentrated sulfuric acid then combined with sulfur 6 oxide, this one will react and then they form a substance called helium. So we have sulfur 6 oxide plus this one, we have helium with the formula H2S2O7. This is the formation of helium. So in some situations where you will be required to explain how is the sulfuric acid being formed, how is this reaction takes place, you need supposed to explain how does sulfur 6 oxide converted to sulfuric acid. You just first say that the sulfuric acid is dissolved in a concentrated sulfuric acid to be converted to be helium. Helium is now taken into the dilution chamber. The dilution chamber now where we have this helium is diluted with water. The helium being diluted with water, and then we have the dilute sulfuric acid being produced here at this side. So the sulfuric acid produced here normally is 98%. Then where is the 2%? So from here you realize that not all the sulfur 6 oxide which has been used to produce sulfuric acid. Not all the sulfur oxide that has been converted to sulfur 6 oxide. So in this case, we can have almost 2% or 3% of these gases. They normally escape into the atmosphere. And when they escape into the atmosphere, they are the environmental pollution. They just pollute the environment. So once these gases goes into the atmosphere, they can combine with the rain and then they form the acid rain. When it rains back, that acid rain, the waters will just flow into the lakes and oceans. What will happen? It will kill the aquatic animals. It can also cause the cracking on buildings. It also causes what you call the stunted growth in plants. So this 2% of the gas normally goes to the atmosphere, where I've said that the gases will go into the atmosphere. If they go to the atmosphere, they becomes a pollution effect on the environment. So in this case now, you will be required to explain the environmental effect of this gas. The environmental effect: sulfur oxide dissolves in rainwater. Sulfur oxide dissolves in rainwater, forming acidic rain. Acidic rain, it destroys the metallic roofs and the stonework. So you will be required to explain the effect of this sulfur oxide in the atmosphere. It is just combined with rain to form the acid rain, which in this case destroys roofs and the stonework. So how is this gas being prevented from the atmosphere? Sometimes now you have methods of reducing pollution. We have the pollution effect of this gas. How do you reduce now this gas from the atmosphere? There are normally two methods. One, we call it the scrapping method. Scrapping method is a situation where when these gases is passing through the atmosphere, the chimney where the gases are passing are escaping into the atmosphere, it is being lined with a substance called the calcium hydroxide. So as the gas passes through that chimney, it will combine with the calcium oxide, the calcium hydroxide, and then it is converted to calcium sulfate and water. In that case now, the gas has been prevented from entering into the atmosphere. We have another method here. Another method is by efficient method. The efficient method of preventing these pollutant gases is by use of the fuel gas desulfurization device. This one, it is fitted into the system to convert the pollutants into a less harmful product, such as the carbon dioxide and in this case we talk of the hydrogen sulfide. So in that case now, the device is just fitted in the system to convert the pollutants into a less harmful event. So if you will be required to explain how is the pollution of this gas being prevented from the atmosphere, so you just say it is by use of scrapping method, whereby the gases being passing through the chimney, it combined with the calcium hydroxide and then converted to calcium sulfate, and then we have water and liquid. Then you can also use this fuel desulfurization device, which is fitted in the system to convert the product or the pollutants into the less harmful product. Now, this sulfur oxide, sometimes you will be required, give a reason why the sulfur oxide cannot be dissolved direct into water. So the sulfur 6 oxide in this case, it cannot be dissolved directly into water because the reaction is high exothermic. If the reaction is highly exothermic, this one will be causing the gas to coil, forming a mist of tiny droplets, which are harmful and difficult in this case to dissolve. So that is the reason why the gas that is sulfur 6 oxide cannot be dissolved directly in water. Sometimes you are also required to give one use of the sulfuric acid. One use of the sulfuric acid, you just say it is used in the manufacture of detergents, surplus detergents. It can also be used in a cleaning of metals. So those are some of the uses. You can get more revision books and get more uses of this sulfuric acid. There is a commonly tested question from this conduct process. After studying the flowchart or going through the flowchart, you will be given an equation in the conduct process. The equation in an conduct process is this one, where we have the equation in the conduct process this conduct process is this one, and this one it normally takes place in the catalytic chamber. So this equation here, it takes place in the catalytic chamber. So what are some of the questions that you are expecting? You will be given this kind of an equation in the catalytic chamber, where the sulfur oxide is converted to sulfur 6 oxide. And then we have an energy given as negative 196 kilojoules. What are some of the questions expected from here? This one will be testing on the factors affecting the rate of the reaction. Factors affecting the rate of the reaction, we get them in form 4. We have the catalyst. A catalyst in that case in form 4, in form 4, when it's affecting the rate of the reaction, it normally lowers the activation energy. We have the concentration, is another factor affecting the rate of the reaction. We have a concentration, we have the surface area, is also another factor affecting the rate of the reaction. We have temperature as another factor. We can also have the pressure as another factor. So in this case here, you have been given this equation and then you will be asked, state what will happen if either the temperature is increased or the temperature is decreased. State what will happen in this equilibrium if the pressure is increased or the pressure is decreased. What will happen if the concentration of oxygen is being added in this equilibrium? So those are some of the questions that you are expecting to get from this part of the reaction which takes place in the catalytic chamber. For instance here, what will happen to this equilibrium? What will happen to the product? What will happen to the product of this alpha 6 oxide if there is an increase in temperature? So there is one thing you need to understand. You need to identify the forward reaction and the backward reaction. In form 4, we have two types of the reaction. That is an exothermic reaction, and then we have endothermic reaction. So in this case here, our forward reaction, the forward reaction here is an exothermic reaction. The forward reaction is an exothermic reaction. And always you need to understand, when there is an increase in temperature, it favors a backward reaction. And the backward reaction here in this case is what? The backward reaction is endothermic. Increase in temperature, it favors an endothermic reaction. So an endothermic reaction in this case here, it is the backward reaction. So when you increase the temperature in this case, the backward reaction will be favored. If the backward reaction will be favored now, there will be a low yield of sulfur 6 oxide. Increase in temperature, so there is also increase in temperature. Increase in temperature in this case, it favors the sites with the fewer molecules. So you will study those factors in form 4. But according to this equation here, when the temperature is decreased, there will be an increase of the yield of the sulfur 6 oxide. So when the temperature is increased, there will be an increase. When the temperature is decreased, there will be an increase in the yield of the sulfur 6 oxide. What will happen in this case if the concentration of oxygen is increased? Increase in the concentration increases the concentration, increases the rate of the reaction. So if the concentration of oxygen is being increased in this reaction here, in this reaction, the concentration of oxygen increases the rate of the reaction. Therefore, there will be a high yield of sulfur 6 oxide. And of course now, you also give the name of the catalyst used in the above reaction. So the name of the catalyst in this case, we are talking of the vanadium 5 oxide. It is the commonly used catalyst because of the two reasons. It is cheap and it is not poisonous. So that is a very simple summary of the conductive process. This is a simple summary of the conductive process. You can go through it, get revision books, get the kcse past papers, and check some of the questions which are being set from this conduct process. We have come to the end of our discussion. You kindly follow my channel, subscribe, click the notification bell, you get notified once I upload a new video. Thank you for watching.